Hello, this is day 2 of Unit 4 or Chapter 3B, Nature of Graphs. This is the second day of inverses. So there are a couple more things. We'll have another way to find an inverse of a function, and there's also something called the horizontal line test. And really what that relates to is the difference between a relation and a function. So a relation is just a mapping of x and y coordinates. So you have an xy ordered pair. And then you have a number of these, x, maybe this is a point and this is a point, and so forth. But what a relation is any set of points. A function, it has to be a one-to-one mapping of x and y pairs. And what that means is you could have, let's say, 2, 5, 7, 2, 0. And these are just ordered pairs. 1, 3, and then 0. Let's do 5. And then 2 is going to be the difference. Let's say we have 2 there. This would not be a function because for any unique x value, it has to map to exactly one y value, or their pair has to be unique. So 2 and 4 is a pair, 5, -1, 7, and 3, and then 2 and 2 is a pair, meaning that I have 2 entries of x going to 2 different y values. So this is not a function. It would be a function if in this list 2 also went to 4 and it was just repeated. Then it would be a function. And you can think of it as things that are really good functions, like a website is a really good function because if you type in, google.com, you'll go to Google's website. What would be an example of if it weren't a function? That would mean that sometimes you type in google.com and you go to yahoo.com. And so it has to be consistently a one-to-one mapping of x to y values. So every x has to go to exactly one unique y value. That's what makes it a function. Previously, we had done something called the vertical line test to test for a function. And so let's, if we chose, let's say let's do an x to the third graph. Maybe it looks like this. This is a function because I can draw a vertical line anywhere on this graph, an exactly vertical line, and it will only cross my graph, the curve of my graph, at one spot only. It will only cross at one time. See, once. However, and those are all functions that graphs we've seen. If I had a function that looked like this, it actually wouldn't be a function, but I have a function that looked like, let's say, that's not great. That. Some kind of graph that goes like this. This would be vertical line test. I know right now it's not a function because it crosses a vertical line that I can draw anywhere, crosses this graph at 3 points. Anything more than 1 means it's not a function. Why we're calling it a horizontal line test is that's how you would test to see if your inverse is a function. So if f of x passes the horizontal line test, then f negative 1 of x, that's the inverse. It's just a notation for calling it an inverse. Then the inverse is a function. So we would say, if we had a parabola and we did a horizontal line test, I know that this parabola is a function, passes the vertical line test. So f of x itself is a function. But if I do a horizontal line test and it crosses it twice, that tells me that the inverse of this is not going to be a function because it crosses it twice. Okay, so we'll get into that. But really, the other method, instead of creating a list of ordered pairs and then swapping them like we did before to get the ordered pairs of the inverse, there's another method that's perhaps a little faster and probably easier. Instead of f of x, we'll call this y. That's the same thing what we do when we graph. You can call it y. To find the inverse, you swap your x and y values in the equation. Now this is hard to graph. Usually we have it as y equals, so this is where we have to do a little bit of work. So first step, swap your x and y values. Second, we need to solve for y. So we're just going to move everything. We're going to get y by itself, move everything to the other side to belong with x. The first step, y is trapped inside the parentheses. Has a -1, but it's in parentheses, can't get rid of it. And then it's squared, so I have to get rid of the square. But I have this 3 hanging out over here, so let's get rid of that. So this is just regular solving for a variable. We have x minus 3 equals y minus 1 squared. To get y by itself here, to free it up from the squares, we square root both sides. When we square both sides, you have to have a plus or minus over there. We can't do anything on the inside. This is x minus 3. And then y minus 1 is freed up. And then to get y by itself, the last step would be to add 1. And these won't be like terms. We'll just have a 1 over here. So it'd be positive or negative square root x minus 3 plus 1 equals y. This is the inverse function. You could also write this as 1 plus or minus square root x minus 3 if you wanted, but this isn't as conducive to recognizing what the transformations of the parent function of square root of x is. We can readily see it's right 3 up 1 from the parent function of the square root. But then you also have the second part of the function where it's a negative out front. So this is like two functions here, but this is the inverse. And this is why, this is where we can tell, is this going to be a function or not? We could tell that right away. If we graph this this function, x minus 1 squared plus 3, we would say this is just a parabola and it's translated right 1 up 3. So right 1 up 3, it's just a regular parabola, goes up like this. If we did the horizontal line test right now, and this graph isn't perfectly accurate, but surely it's close enough given the transformations we know and the shape of the parabola. If we did a horizontal line test right now from the regular function, we would see that it crosses our graph twice. That means that it failed the horizontal line test. The inverse is not a function. Similarly, if you graph both of these things in Desmos, meaning that one of them has to be positive square root x minus 3 plus 1 and a negative square root x minus 3 plus 1. It's two separate functions, kind of just conjoined as one. Two separate functions in Desmos, you get something that looks like, let's see, right 3 up 1. So right 3 up 1, it goes off like this. And then right 3 up 1 as well, but it's flipped upside down because of the negative up front. It would look like that. And so this is the graph of the inverse. And anytime you want to check if a graph is a function, you do the vertical line test. Any function or any graph, you can test if it's a function by doing a vertical line test, and it would fail it. We knew it would fail it because I did a horizontal line test from the original function, and that already told me what I wanted to know. So to sum it up, find the inverse, that's f to the negative 1. Looks like that's just a notation for inverse function. So find the inverse for each function, then tell whether it is a function or not. Well, if I graphed this thing and did a horizontal line test, well, I already knew this part. It failed the horizontal line test. The inverse is not a function. But to find what the inverse is, this is the process. Swap your x and y and solve for y. Okay. So we could try this one. We'll need, we can kind of tell what the graph will be. It's an x to the third, so it's kind of like a snake, but it's translated. So we would say left 5, down 8, from where 0, 0, the vertex would be. Left 5, down 8, it's right here, let's say. And our graph in general is just kind of like a little snake thing like that. So right now we could tell whether or not the inverse is going to be a function. And this is g of x, so we're saying g, oh, that's a crazy g. G inverse of x is, and if we did a horizontal line test to this function right here, we would see that anywhere on this graph that I cross it with the horizontal line, it's only gonna cross my graph once. So it is a function, and we're talking about the inverse. To find the inverse, we would swap, this is a y, we would swap our x's and y's. So this is an x over here equals parenthesis y plus 5 to the third minus 8. And so we just need to get y by itself. Start by adding 8. And then we need to get rid of the exponent. So we'll take a third root to cancel it out. And with an odd indexed root, we don't need to have the plus or minus. So this will be cube root. X plus 8, 8 is under the root, and then y plus 5 is now freed, so we can subtract 5. So this would be the cube root of x plus 8 minus 5 equals y. This is an inverse of our original function, and I was careful to say this is the inverse function, not to say that because we wouldn't know yet, but we actually already do, because g inverse of x is a function. We already know that from the horizontal line test. It may be helpful, though, at times to type some of this into Desmos. So just so we can get a picture, I'll do that here. We want a third root. I wonder if it'll let me do that. It won't, but there's a workaround. Recall that a root is also a fraction exponent, so it would be to the 1/3 power. So I'll say x plus 8, and then raised to the, and then minus 5. So we can look at this function, what it makes. We can also put the original one in. It was x plus 5 cubed minus 8. And you can kind of see how this inverse works. They are a reflection across that line, y equals x. But we could also see readily that the blue function, the inverse, we already know it's a function because it passed the horizontal line test for this function, for our original function. But you can tell any graphs if it's a function by doing a vertical line test. So that could be a little confusing. But any function, any graph is a function if it passes the vertical line test. You can work around all of that and test right away a regular function if its inverse is a function by doing the horizontal line test. So here's another example. The rational functions, so its parent function is 1 over x, and the graph is the weirder one. That's kind of like that. They're not continuous, it doesn't connect, but we could test to see if it's a function or not right now. We would just do the horizontal line test to this function, and we may want to kind of get a glimpse of this on Desmos. 2 over x plus 9. 2 over x plus 9. You see it's over here, looks basically the same translated. There is a dilation, but it doesn't appear very noticeably on the graph. And so if we did a horizontal line test, we're going to only cross the graph at any spot one time, wherever you draw a horizontal line. So it would appear right now that it is going to be a function. The inverse will be a function. And then to find what the inverse is as an equation is to swap your x's and y's. So remember, f of x is, you can think of it as y. So x equals 2 over y plus 9. And this is a little interesting. We kind of have some experience with this to solve, but this may be a little confusing at first. I want to notice right away that I have a fraction equaling a fraction. Whenever you have that, so see, x is a fraction over 1. Whenever you have something like this, it's nicest to cross multiply. 1 times 2 is 2. And then x times y plus 9. Now to get y by itself, yeah, we need to subtract by 9, but that's stuck inside the parentheses. So we need to get rid of the x first. And it's multiplying the y, so we would divide by x. We'd have 2 over x equals y plus 9. And at that point, we subtract 9. So those look like g's, but they are 9s. So this looks like 2 over x minus 9 equals y. So it might be kind of fun to put that into decimals to see what it looks like. 2 over x. And you see it's over there. Edo. All right, so again, just an overview. You can test to see if an inverse is going to be a function by using the horizontal line test on the original function. So graph it and then draw a horizontal line anywhere. It can only cross it once. If it does only cross it once, then the inverse is a function. To find what the inverse is, the inverse of a function is, as an equation, is you substitute x and y for each other. So you swap them in the equation and then go about solving for y. Just moving things to the other side, getting y by itself. And what you're left with is the inverse of your original function. All right, great. I hope this helped, and good luck.